This week I will talk about John William Strutt and his theory of sound. John William Strutt is a British physicist who was born in 1842 and was awarded a Nobel Prize in 1904 for the discovery of argon. He is also well known for his work in light waves, which has to do with his explanation of why the sky is blue. He calls this Rayleigh scattering, which has to do with light entering the atmosphere and being absorbed and then re-emitted by the particles. And as the light is re-emitted, the wavelength that is re-emitted falls into the blue spectrum. He is also accredited for discovering Rayleigh waves, which are the surface waves on a solid object. You can visualize this as if you were to drop a marble on a piece of jello. That jiggling would be described as Rayleigh waves. His theory of sound proposes that sound is a vibration in an elastic medium. This medium can be air, water, solids, etc., and this leads to the creation of pressure waves due to compression of that medium. He proposes that sound waves travel in a sinusoidal pattern. The velocity of sound is dependent upon the density of the medium. The more dense the medium, the faster the velocity of the sound. This is why we know sound travels faster in water than it does in air. In water, the particles are closer together and can vibrate much more readily against each other. Frequency is related to pitch. The higher the frequency, the higher the pitch. Amplitude of the wave, or height of the wave, is related to the volume perceived. The greater the amplitude of the wave, the louder we're going to perceive it. He also proposed constructive and destructive interference, which has to do with the sinusoidal patterns of the wave overlapping. And he also said that sound radiates outward from all points at the origin of the sound. He called this propagation of sound. Using his theory of sound, we can better understand how we perceive sounds today. So sound waves enter the ear, and these pressure waves will vibrate the eardrum, and these vibrations of the eardrum are amplified by the bones in the ear, the malleus, the incus, and the stapes. The stapes vibrates fluid within the semicircular canals, specifically through the oval window, and this allows for the compression of fluid, which creates further vibrations that travel into the cochlea, where we know there is hair cells located within the organ of corti. These hair cells send electrical impulses depending on their compression due to those vibrations. These electrical impulses from the hair cells are then interpreted as sound waves in the brain. Thank you.